private neighbor of the vertex V in S is a vertex W with the property that the only neighbor of W in S is V. Okay? You look at the figure, you take a subset S, a vertex W, W has only one neighbor in S. Okay, W has only one neighbor in S. So that W is called the private neighbor of the vertex V. So if a dominating set is minimal, then every vertex in the dominating set has a private neighbor. Is that clear? If a dominating set is a minimal dominating set, every vertex in the dominating set will have a private neighbor. By a private neighbor, I mean a vertex whose only neighbor in the set S is the vertex V. Okay. So a dominating set S is a minimal dominating set if and only if every vertex in S has a private neighbor. Okay. Every vertex in the set S has a private neighbor. So this property I take and coin a new term. Coin a new term. What's the new term? The new term is irredundant property. Irredundance. Like domination, I talk of irredundance. So what is an irredundant set? Okay, irredundant set. A set is called irredundant if every vertex in that set has a private neighbor. That's all. I forget domination. The minimality of dominating set becomes the definition for the next property. That's the idea. Okay. Minimality of that dominating set becomes the definition for the next property. A subset S of the vertex set is called irredundant set if every vertex in the set has a private neighbor. That's all my definition. For example, if we take a cycle on 6 vertices and take V1 and V4, you see V2 is a private neighbor of V1. Is it correct? Because the only neighbor of V2 in S is V1. V2 is a private neighbor of V1. V5 is also a private neighbor of V1. Is that right? And similarly, what's a private neighbor for V4? V3.
V3.
Is a private neighbor for V4. V5 is a private neighbor for V4. So V1, V4 is a irredundant set. So irredundant set means every vertex in that set has a private neighbor. And then this is a hereditary property. I take the maximum and minimum cardinality of a maximal irredundant set and call it irredundance number and upper irredundance number and denote it by the symbol IR and capital IR. The bottom is the screen. IRG is the minimum cardinality of a maximal irredundant set and capital IR is the maximum cardinality of a maximal irredundant set. Okay. Now you see, by the very definition, any minimal dominating set is maximal irredundant. So irredundant sets include minimal dominating sets. Therefore, when you take the minimum, it will be less than gamma, and when you take the maximum, it will be bigger than capital gamma. That is, this IR and capital IR will come and sit at the end here, like this. IR here and capital IR here. So you see that irredundance, domination, independence. Okay? Irredundance gives two parameters, IR and capital IR. Domination gives two parameters, small gamma and capital gamma. Independence gives two parameters, I and beta naught. So these 6 parameters form a chain of inequality. So this chain is called domination chain in graph theory. It was first observed by Cockayne in 1960s, late 1960s. This single inequality chain has become a topic for nearly 100 research papers in graph theory. Because you can ask so many questions when 2 of these parameters are equal. Okay? Given 2, can I get a graph with one parameter equal to A and another equal to B? You keep on asking several questions about these 6 parameters, the domination chain of the graph. Okay, fine. For example, I ask one question. I give you 6 integers A, B, C, D, E, F. A less than or equal to B, less than or equal to C, less than or equal to D, less than or equal to E, less than or equal to F. I'll ask a question. Can we give me a graph G such that IR equal to A, gamma equal to B, I equal to C, beta naught equal to D, capital gamma equal to E, and capital R equal to F? Under what conditions, given 6 integers, I will get one graph G where there are 6 integers. Let me take only 2 numbers to start with. Small gamma and capital gamma alone let me take. Let me take small gamma and capital gamma. I take 5 and 8. I ask you, can you give me a graph with gamma equal to 5 and capital gamma equal to 8? That's how I ask the question. That's I want a graph whose domination number is gamma is 5, upper domination number gamma is 8, capital gamma is 8. Do they exist? Such a graph exists or not? Okay. First of all, let me take a graph with gamma. That we can easily give. Can you give a graph with gamma equal to 5? That's very easy. A graph with gamma equal to 5. For example, you take cycle on 15 vertices. What is gamma? What is for a cycle? What is gamma? N by 3, right? So floor N by 3. For every 3 vertices, you have to choose one. Okay. So if there are 15 vertices on the cycle, I will choose V1, then skip to V4, skip to